This very short section gives some terminology that will be used later in the chapter. The activity in a neuron, that is, the transmission of an impulse, depends on changes in the membrane potential. The membrane potential is an unequal charge distribution across the membrane. Cells are more negative inside than they are positive. These changes are due to ions. There are more negative ions inside than outside the cell. And according to this picture here, you can see that proteins contribute to this negative charge. Of course, both inside and outside the cell, you're going to have both negative and positive charges. However, inside is more negative than outside. These ions carry electrical charges, and this is where we get this electrical potential. There is a difference. The membrane potential says there is a difference across the membrane, an unequal charge distribution. And this is due to the cell's permeability to various ions. The membrane is a little bit like a battery, and that it has potential energy that can do work. The resting membrane potential, or resting potential, is the charge distribution on a resting cell. That is, slightly more negative inside compared to outside. A graded potential is a temporary, small, and very localized change in the resting potential. That is, there's been a switch of the membranes, so the inside has become less negative. This graded potential acts at a specific spot on the axon hillock, and it decreases with distance away from the stimulus. An action potential itself is triggered by a large enough graded potential. And the action potential is an electrical event that involves one location on the axon membrane, that is, a switching of the charges, but it spreads along the axon surface toward the end of the axon terminals. As that action potential moves toward the end of the axon, it is going to trigger the release of neurotransmitters from the presynaptic cell. The neurotransmitters are released from the presynaptic neuron, travel across the synaptic cleft, and bind to receptors on the postsynaptic cell membrane. This changes the membrane and changes the potential of that membrane, and it produces a graded potential. That postsynaptic cell is then going to respond depending on the changes, the graded potential. And this is the simplest form of information processing in the nervous system. An example of this would be the neurotransmitter that's released may be inhibitory or may be excitatory. But keep in mind that many, many neurons may synapse with a single neuron. So you might have 1,000 presynaptic neurons synapsing on a single postsynaptic neuron, each one releasing different neurotransmitters. And the end result, whether a nerve impulse is stimulated to go or if it stops, is determined by processing at that postsynaptic neuron.